Hello, so in this video I'm going to talk about this question. So this is taken from an admissions exam called STEP, which is an admissions exam for mathematics at the University of Cambridge. But actually everything in this question is pretty much accessible just using what you already know. So I think the best thing to do would be for you to try this question first, and then if you get stuck, then start watching my solution, which I'll start in a minute. Okay, so just one or two things to point out. Firstly, this word integer, hopefully we know that means whole number, and also this word real solutions in part 3, that means real numbers. Those are the kind of numbers you know, so that could be anything, including things in terms of radicals, that is roots. Okay, so part 1, well, we've got this. So we just need to expand the brackets. And there is a method that speeds this up a little bit, which is something called the binomial theorem, but I don't have time to go into that today. So I think what we'll do is just expand the 3 brackets. So notice for the first two, 3 times 3 is 9, and 2 root 5 times 2 root 5 is 20. So this is 29 plus 2 lots of 6 root 5, so 12 root 5. And then if we expand this, well, 29 times 3 is 87, and then 12 root 5 times 2 root 5 is 120, so this is 207, and then we've got 36 root 5 plus 58 root 5, and then, so that's 94 root 5. So we get 207 plus 94 root 5. And that's it. So then part 2, which is where the question gets much more interesting, find positive integers c and d such that the cube root of 99 minus 70 root 2 is equal to c minus d root 2. Well, I mean, I think the best thing here would be to cube both sides. So if we cube both sides, we get 99 minus 70 root 2 is c minus d root 2 cubed. And then we know we could expand this. And then the strategy is if we compare the terms that involve root 2 and the terms that don't involve root 2, we'll be able to set up some simultaneous equations. And this will work out nicely because c and d, we're told, are positive integers. So if we cube this, how would we cube this? Well, we have 3 brackets to expand again. So this is a lot like the previous part. So if we expand the first 2, we've got c squared, and then d root 2 times d root 2 is 2d squared, and then we've got minus 2 lots of cd root 2. And then if we multiply everything by c, we've got c cubed plus 2cd squared minus 2c squared d root 2. And if we multiply everything in the first bracket by minus d root 2, we get minus c squared d root 2, minus 2d cubed root 2, and then plus 2cd squared. And if we collect together like terms, we've got c squared plus 4cd squared. And then, oh, sorry, that's not quite right, is it? Because this shouldn't be a 2 here. I'll do it a different color. In red, this should be a 4, because root 2 times root 2 is 2. So we get c cubed plus 6 cd squared. And then we've got minus 3c squared d root 2 minus 2d cubed root 2. And we need this to be the same as 99 minus 70 root 2. So if we compare the terms that involve root 2, we need these terms underlined in blue to be the same. We need there to be the same number of root 2's on both sides. So we need minus 70 to be equal to minus 3c squared d minus 2d cubed. So here we're sort of equating the root 2 terms, the coefficients of root 2. And then if we equate the terms that don't involve root 2, if we equate the integer terms, we get 99 is c cubed plus 6cd squared. So in this first equation, maybe if we just multiply everything by -1, just to make it slightly nicer, we've got this. So this is equation 1 and this is equation 2. And then perhaps if we factorize these, we've got, so equation 1 becomes d lots of 3c squared plus 2d squared is 70, and equation 2 becomes c lots of c squared plus 6d squared is 99. And then we know c and d are positive, and we know that the brackets with the squares are also positive. So what kind of number could D be? Or what kind of number could C be? So maybe I'll just make the comment before I go on that I'm sure you could solve these algebraically, but I don't think it's very easy. It would be quite difficult to solve, but we can certainly work out some possible values for D and C using these equations. Because in the first one, notice that D has to be a factor of 70. And 70 doesn't have that many factors. The only factors of 70 are 1, 2, 5, 7, 10, 14, 35, and 70. And we know that, so what could D be? Well, D could be 1 or 2. Could D be 5? Well, if D is 5, then we can see that the d squared terms in these brackets are going to be too big, because 6 times 5 squared down here is 150. That's too big, so that's not going to work. So D can't be 5. It can only be 1 or 2. So let's see what happens if D is 1. What do we get? We get 3c squared plus 2 times 1 squared is 70. So 3c squared is 68. So c squared is 68 thirds, which isn't an integer. Oh dear. We know c is an integer, and we know when we square an integer, we get an integer. So this is a problem. So this means c is not an integer. So this can't be right. So therefore, d is not equal to 1. So if c squared is not an integer, c isn't an integer, so that doesn't work. So d has to be 2. And once we know d is 2, we can work out c. So now we've got, in equation 2, we've got c, or maybe if we use equation 1, we've got d is 2, so we've got 2 lots of 3c squared plus 8 equals 70. So 3c squared plus 8 is 35. So 3c squared is 27. So c squared is 9. So c is plus or minus 3. But we're told they're positive integers, so c is 3. Okay, so d is 2, c is 3. So therefore, the cube root of 99 minus 70 root 2 is 3 minus 2 root 2. And you can verify that on your calculator. I forgot to mention STEP is a non-calculator exam, so you wouldn't be able to just put this into your calculator because it might be able to do it for you, and that kind of defeats the point. So then there's a third part. Find the two real solutions of x to the power 6 minus 198x cubed plus 1 equals 0. I'll just double check I've got that right. Yes. Okay. So this is a cubic equation. Sorry, not a cubic equation. This is an equation with a power 6. So looks like it'd be really hard to solve, but I claim it's really a quadratic equation in disguise. Because if we make a change of variables, if we let y be x cubed, it turns this equation into y squared minus 198y plus 1 equals 0. And then we can solve this using the quadratic formula, or by completing the square. So we obtain y is 198 plus minus this all over that. Okay, so 198 over 2, that's easy enough, that's 99. 198 squared minus 4 all over 2. Well, maybe if I include the 2 inside the root, it becomes a 4, and we get this. And then 198 squared over 4 is, well, that's the same as 99 squared, because we can half each of the 198s. So this is 99 plus minus root 99 squared minus 1. And then, well, notice this is a difference of 2 squares. So this is the same as 99 plus 1 times 99 minus 1, like this. And then if we simplify that, we can make this 10 root 98. And then root 98 is the same as root 49 times root 2. So this is 70 root 2. So that's what y is. And y is x cubed. So therefore we know x cubed is 99 plus or minus 70 root 2. So what is x? Well, now if we go back, I think earlier, no, we worked out cube root of 99 minus 70 root 2. Oh yes, that's one of the things we've got. Good, okay. So we already know x is going to be the cube root of 99 minus 70 root 2, or the cube root of 99 plus 70 root 2. We just worked out what this one is in the previous part. This was 3 minus 2 root 2. And then the other one, I'm guessing, is going to be 3 plus 2 root 2. But we ought to check that. So how could we check that? Well, we could cube 3 plus 2 root 2 and just check what it gives us. So, oh, did we do that in the first part? No, we cubed 3 plus 2 root 5. Okay, so if we cube this, we've got, again, 3 brackets to expand. So the first 2 brackets give us 17 plus 12 root 2. And then, so we've got 17 times 3 is 51. 12 root 2 times 2 root 2 is 48. 51 plus 48 is 99. And then we've got 12 root 2 times 3 is 36 root 2. Plus 34 root 2 is plus 70 root 2. So it works. Good. So therefore we've shown the only solutions to this equation are 3, the only real solutions are 3 plus minus root 2. And we're done. So that took us quite a long time to solve, but it's worth bearing in mind STEP is a 3-hour exam. It's actually 2 3-hour exams. And in each exam you have to answer 6 questions. Well, ideally at most 6 questions. You're only scored on your best 6 questions. So that means, but in practice, many people aim to answer 4 good questions, which is usually enough to get a grade 1. So that means really questions are designed to take about 45 minutes each. Maybe a bit less if you're very good at what you're doing. But so I think we'll end there. Please do let me know if you've got any questions, and I'd be happy to get back to you.